Hello, I'm Jasmine Manzano, and today I'll be presenting a case study titled Caffeine Consumption and Heart Rate. To begin, this is a really nice abstract that gives a good overview of the entire study. However, I'll just give you a quick gist of some of the details that will be discussed later in the coming slides. As you might imagine, the study was created to explore the effects of caffeine on heart rate. The hypothesis is that there would be a positive correlation between heart rate and caffeine consumption, meaning that we would just expect heart rate to increase as the amount of caffeine consumed would increase. So for a bit of background, I was interested in creating this study to look more closely at the side effects of caffeine, especially heart rate, because I myself experienced some of these side effects as well as others that I know, so I wanted to quantify these a bit more. After taking a look at the literature, I learned that approximately 85% of the United States population consumes caffeine daily. As you can see in the figures on the slide, a big portion of caffeine intake comes from coffee, which is one of the main reasons coffee was used as a source of caffeine for the study. This was also a choice made for convenience, given that we do have a Starbucks on campus. So moving on to our methods, our participant was a 20-year-old female that is moderately active and has a moderate caffeine sensitivity. The variables for this study included the number of caffeine milligrams as the independent variable, the pre and post heart rate recordings as the dependent variable, and the controls are the trials replicated with water instead of coffee. For our analysis, we used descriptive statistics on our data as well as Pearson correlations. Moving on to our methods, I want to make it clear that the data was recorded at the Starbucks on campus early in the morning for the coffee trials, and the water trials were recorded in the dorm. So, to begin each trial, a baseline resting heart rate was recorded at approximately 7:30 a.m. Next, the participant consumed the designated amounts of coffee in the form of espresso shots. After approximately 45 minutes, a post heart rate was recorded. We waited 45 minutes because the literature showed that it takes approximately that much time for our bodies to absorb caffeine. These heart rate recordings were recorded on a Samsung Health app via the right pointer finger of the participant. Excuse me. This process was repeated on alternating days with an increase of 1.5 milliliters of espresso shot each trial. The control trials were identical besides the location, like I said before, where they were in the dorm. However, the participant was still in the resting state and everything else was the same. And other than obviously the espresso was replaced with the same amounts of water. Moving on to our results, the first table on the left shows all our raw data that were collected in the study, and you can see in these columns that it got specific to the dates that we recorded, as well as the specific heart rates, pre and post heart rates. You can see in the fourth column of this figure that these top three trials were the caffeine trials, the coffee trials, and the bottom three were the water trials. And you can see the amount of caffeine in milligrams, how they increase on these days. And then again, finally, the timing of the second recording down to the minute. On the right, we have a visual depiction of the heart rate versus the amount of caffeine, the means of these heart rates. So the blue bars are representing the pre-heart rate, the means of the pre-heart rate, and the red ones are the post. To continue, descriptive statistics were performed on our variables, as well as respective correlations. These can be seen in the tables on the slide. Finally, to connect the study to literature, as I've stated before, it's clear that the focus has been more holistic or more towards blood pressure and things of that nature, and not specifically on heart rate, therefore making some of the literature inconsistent for heart rate specifically. However, there is a usual expected trend that heart rate does increase with an increase in caffeine consumption. This study does support this trend and therefore matches the expected outcome. To get into our more specific conclusions, there was a very strong positive correlation with the value of R equaling 0.978 between the heart rate of the participant and the increasing amounts of caffeine. Our p-value was 0.001. Consequently, the expected outcome or hypothesis that the heart rate of the participant will increase as the amount of caffeine increases can be accepted. There is also a note in here that the original procedure was changed. There was an extra 4th day where a total of 4 espresso shots would be taken. However, this was revised due to some anxiety or discomfort from the side effects that the participant experienced later in the day after the trials in the early morning have been concluded. In the future, the study can be improved upon by recording heart rate throughout the day, recording other side effects, increasing the sample size, having more trials to have more substantial data. That kind of thing. These are the references that I used, and here are some captions if my recording doesn't have them.